So, after a gap for the mid-semester examination, we are resuming. We were talking about that the sequence is getting transformed first in Z transform and then in discrete time Fourier transform. But the problem was that a crude statement which we had made is that something which is continuous function, it cannot be useful to be handled by computers. Therefore, a computer can handle only digitized sequence. A computer can only handle a digitized sequence. Then, since it is our first broad scan, we are aware about the different transforms, say Z transform, discrete time Fourier transform. We do not have any clear idea about the exact meaning and application. But even though we know the application and understand it fully, the problem is that it cannot be implemented, because with computers it's of no use. Then it is remaining only at a hypothetical level. So for whatever we are describing, whatever we are adding some meaning to it by transformation, we should first have a digitized version, a sampled and digitized version of the transform. So, discrete time Fourier transform, it is DTFT, is to be sampled, and the sampled version of discrete time Fourier transform is discrete Fourier transform. But discrete Fourier transform also cannot be handled by computers. What is the reason? Because computer cannot handle continuous things, computer cannot even handle discrete things, but computer can only handle digitized things. So discrete Fourier transform we further digitize and work with the computers. But with very good resolution ADC is available, the difference between discrete and digital is negligible and not taken into consideration. Right? So without specifically mentioning anything, it is possible for us to work on discrete things in theory and implement digital things in practical. That is possible. So the question is the discretization of discrete time Fourier transform. Discrete time Fourier transform is continuous in nature, and we are now digitizing it. Discretizing it. Another thing is that the time unlimited signal is also remaining something which is having significance merely on paper. A signal which has started from minus infinity, a signal which will continue till infinity. Only Almighty can think of such signals, right? Because it has to think about such signal which has started at time minus infinity and which will last till infinity. An individual with a finite lifespan, from that point of view, it does not have any significance as such. Therefore, for all practical purposes, the thing is we work with finite time signals. Then when the concept of sampling theorem was not there, that time also there was a facility of audio recording. Means if we consider today's scenario without sampling theorem, then we can have audio thing which we can view on CRO. Means the complete analog signal is available Since it is recorded, you can reprocess it every time you want. You are now very much expert in, first is transistorized thing, then now linear integrated circuits. So these two things will enable you to design some analog circuit and process the signal, where discrete things do not come into picture. But what has happened that the such kind of processing, the processing cost, not as regards to what we can say monetary cost now, but the complexity of the circuit which is required and changes which can be done in that. So analog signal processing has not remained a major contributor today because of very fast growing digital field. So then what we have for practical purposes, we have some signal which is having started at t equal to 0 and ending at t equal to capital T. Is it clear? So when we talk of signal processing, signals and systems, the signal is something which is having different values at different time instants, starting from 0 and ending with capital T. So that signal is available, that can be processed, reworked like that. But as I have already stated, without discretizing and further digitizing it, the modern computational facilities which are available to us cannot be made applicable in that area. Therefore, the first thing which has taken place is that can I represent the available signal which is continuous in nature by finite values, means its samples, finite number of samples, accurately and completely. Or if not accurately and completely, approximately with very negligible probability of error. So the question is, the sampling theorem is right now not in our consideration as its theoretical part is concerned, but the thing is, when we are having a finite time signal, this discussion is not a theoretically perfect discussion. There is actually one statement which you might read somewhere, that a time limited signal is band unlimited and a time band limited signal is time unlimited. Similarly, a discussion which is theoretically perfect is not understandable, and discussion which is understandable is not theoretically perfect. It's having a new statement. So a discussion which is not understandable can also be not theoretically perfect. Means theoretically perfect cannot be understood. But this, its contrast is not true. That what cannot be understood, it is not that it is theoretically perfect. So what you can have 0 0, you can have 0 1, you can have 1 0, but you can't have 1 1. Means you can, means just like it is said that you can't have a cake and eat it too. Means if you have a very nice cake, well decorated, then if you want to have the cake, it is to be there on the table itself. If you want to have it, you can't eat it. If you eat it, you can't have it. So, a theoretically perfect discussion cannot be understood, and what can be understood is not theoretically perfect. It's what we can say a contradiction. It's a trade-off. Therefore, means suppose, let us say, I can give a very simple example. When you are exposed to, say, coordinate geometry in junior college level, we start with point. Then a teacher starts describing the point by putting a dot on the blackboard and say this is point P. So which is said that most or all of the students in the country understand. Everywhere the coordinate geometry at standard 11 begins with the teacher goes on the dais, has a chalk and puts that, let us have this point P. Right? And it is at least understood or pseudo understood by all. But the thing is that it is theoretically completely wrong because it is not a point. So because point doesn't have any dimension, then if teacher starts at standard 11, we now begin the study of coordinate geometry. The fundamental concept of coordinate geometry is a point. A point is that entity which does not have any dimension. It's a theoretically perfect statement and obviously it cannot be understood. So it leads to the science of learning that at an initial stage the preference be given to understanding which may not be theoretically perfect, rather which is theoretically inverse. Not only perfect, but it's imperfect. In some times it's exactly opposite. But hoping that the students' understanding grows as they grow, they would be in a position to understand something which is theoretically perfect on their own, even though they are taught the concepts exactly reversed. So that after learning for quite some time, an individual comes to know that even though teacher started with that point P on the blackboard, the point is not, means it's actually it's a filled circle. What teacher has shown is the filled circle. The teacher has shown point P is a filled circle, and then we come to know that point is the center of that filled circle. That is the understanding. So now we make a statement that the signal has got values at all time instants starting from 0 ending with capital T. Means with what we can say, this is the signal of interest. Means on which we want to work, we want to process. Means now the signal of interest is the signal which is existing between existing between t equal to 0 and t equal to capital T. For time being, let us say it's a one-dimensional signal. For time being, it can be two-dimensional also. So at t equal to 0 and t equal to capital T, and this is signal x of t, and obviously is it clear? So a signal for finite duration of capital T starting from 0 is represented by this graph. How much points are there in this graph for the signal? Infinite. So since it is continuous in nature, a continuous one-dimensional signal for finite duration is represented by infinite points. Right? Then the problem before us is that if this is to be completely processed, then we want this completely, means it's recorded version, and it can be processed with analog circuits. If ever we want to make use of computers, computational power, then this in the present form is of no use. So now the question is, we have to discretize, means the signal which is represented by infinite points. Now what we would be doing is we will take finite number of points, finite samples, which can be as many as you please, but finite. Right? Which can be as many as you please, but these are finite samples. And we digitize them. We digitize. It's discrete. We digitize. But this digitization and discrete we right now ignore. So now the question is whether the signal for finite duration capital T can be completely represented, means the complete information in this, can this be contained in finite set of points? Are you getting me? The continuous signal was there, it was represented by infinite points. So infinite points made up a continuous signal, original signal. When we are sampling, what we are doing? We are not carrying the information which was there, all information we are not carrying. We are collecting samples, we are taking some information. Now, suppose if that there was some student absent for a particular lecture. We have this recorded version. So if it is viewed, it is fully known. But for some reason, or let us consider it in the last semester when such facility was not there, or for some other lecture where this facility is not being used. So the absent student asks the present student. Then what? Presuming that the absent student cares for knowing the contents discussed during his absence. If this presumption is true, then the present student will try. Present student is not a recorder. If he is a recorder, then like this, then everything is known. But not, then he must have noted down something, points in the notebook. So the notebook is given by the present student, absent student. He reads it. But that may not be fulfilled. So present student will try to explain to absent student some key points. Now the question is it possible that the complete information discussed during the lecture can be transferred to the absent student? Yes or no? That depends upon the information. Suppose if that a common off has taken place and the lecture was just after the common off lecture, for which many were present and that few students were absent. And then for the entire hour, the teacher has said that you are hopeless students. you deserve to be detained, and like that. What? So in such case, means if the teacher repeats the same sentence for 100 times in the lecture, then the present student will explain the absent student. The absent student will ask what was taught what was said in the lecture. Then the present student will say that teacher said for 1000 times you are hopeless. 500 times you are useless. And 100 times that you should be detained. So the entire discussion for 1 hour is represented in 3-4 samples. So these 3-4 samples completely represent the signal because it doesn't carry much information. So I hope you are getting it. So depending upon what is the original signal, whether the samples will represent it fully or not will depend on that. But there is a simple common sense discussion which is understandable but may not be theoretically perfect, that if you take more samples, then obviously you represent more information than the original signal. If you take less samples, it will be less information. Whether it will be with more samples, it will be more. If it is complete, then there is no point in more than that. But reasonably, what we can say, sufficient information can be collected by taking samples of the original signal. Are you getting me now? We will have a brute force or a broad or crude statement of sampling theorem, that is the we you have some signal? That is, we are now working with a finite time signal which is there for a time capital T. The original signal is sampled and its samples are available, and if we have sufficient number of samples, then those samples represent approximately all the information in the original signal. Therefore, working with samples is as good as working with signal. Are you getting me? Working with samples, you are working with samples or signal? So I am very much sure that everybody has got convinced that once we have sufficient large sampling, means at close intervals or at smaller intervals, it can be said that samples can represent the signal. So processing samples is as good as processing signal. Therefore, now what we are available with what we have with us is this, we can be said now, this xt which is existing for 0 to capital T is sampled at an interval delta t, and we have with us x0 till so the signal from xt from t equal to 0 to t equal to capital T is now converted into xn with n equal with xn to 0 till capital N minus 1. So a signal for the duration capital T is converted into a capital N point signal with this delta T is equal to T upon delta T is equal to T upon N.